A set is simply a collection of numbers. And for every set of numbers, you need to be able to identify 4 characteristics: the mean, the median, the range, and the deviation. To find the mean, you simply add up all of the numbers. We call that your sum. Then you divide that by the number of numbers in your set, and that's equal to your mean, also known as the average. Both the median and the range require that you first put the numbers in sequential order from lowest to highest. So in this case, my numbers could be rearranged as -7, -4, 1, 2, 3, 3, and then 6. If your set has an odd number of numbers, then the median is simply the middle number after you've arranged the numbers from lowest to highest. So in this case, my median is 2. If your set has an even number of numbers, then the median is actually the mean average of your 2 middle numbers. And this is something we covered in the averages video. The range is simply the difference between the highest number and the lowest number. So in this case, my lowest is -7 and my highest is 6. So my range is 6 minus -7, which is the same thing as 6 plus 7, or 13. Standard deviation refers to how far each number is away from the mean of the set. You won't have to calculate the standard deviation of one set, but you may have to compare the standard deviation among multiple sets. If you understand that standard deviation is simply a measurement of how far apart numbers in a set are away from the middle of the set, then a lot of times you can estimate and rank deviations without a lot of calculation. For example, we could clearly see that in the set number 4, where all of the numbers are 3, there really is no deviation. They're all going to be equal to the mean. So that definitely has the lowest deviation. In set number 2, we still have our numbers fairly close together. We have a lot of grouping with our 3's, and then our 2 and our 5 aren't too far away from the middle of our set. So we could fairly estimate that group number 2 has the second lowest deviation. Sets 3 and 5 both have numbers over a pretty big range, ranging from -5 all the way up to 15 in both sets. But because group number 5 has one extra number that is 15, meaning it has an extra number that is as far away from the middle of the set as possible within that set, we could fairly assume that group number 5 has the highest deviation. So simply put, if numbers are grouped together, such as 1, 2, 3, 3, 4, 5, they're probably going to have a low deviation. And if numbers are far apart, like -5 and 0 and 10 and 15, they will have a higher deviation. There is an equation out there to calculate the actual deviation, but most likely you'll never have to use it. So in this question, the problem asked us to rank the sets in the order of their deviation. Right off the bat, we can see that set number 2 clearly has the lowest deviation because there really is no deviation. But when we compare sets 1 and 3, it gets a little bit more complicated. In set number 1, every number is about 1 apart. So there is some deviation. Set number 3, however, has this group in the middle with no deviation, and then 2 numbers on the sides with a lot of deviation. So to figure out which set has the higher deviation, we're going to have to estimate with a little bit more detail. Our first step is going to be to calculate the actual mean or the average of sets 1 and 3. Set number 1 is going to be fairly easy because, as we learned in the consecutive numbers video, when numbers are evenly spaced apart, the middle number is also the average. So we know 74, that's our average. So then we can just calculate how far each number is away from the average. Well, 74 is the average, so that number is 0 away from the average. 75 is 1 away from 74, 76 is 2 away, and likewise with 73 and 72. With set number 3, we're not so lucky. We're going to have to do this one the old-fashioned way. So our equation for the mean of the set, or the average, is going to be our sum divided by the number. That's our average. Or in this case, the sum is 62 plus 3 74s plus 89. And then I'm going to divide that by 5. When I simplify, I get 373 divided by 5, or I get an average of 74.6. Now I'm going to list out how far each number in set 3 is away from the middle, or the mean, which is 74.6. So 62, that's roughly 12.5 away from 74.6. All my 74s, they're each 0.6 away from 74.6. And 89, that's about 15 or so away from 74.6. Now it becomes clear. If I add up 12.5 and 0.6 and 0.6 and 0.6 and 15, that's going to be much, much bigger than my deviations of 2, 1, 0, 1, and 2. So set 3 has the highest average deviation away from the mean of the set. Even though you'll never have to calculate the actual deviation of a set, you will have to know what to do with the standard deviation if they give it to you. So in this case, they tell us we have a mean or an average of 15 and a standard deviation of 2.5. And then they say x is 2 deviations above the mean. So that just means that if you had 15 and then went to the right a space of 1 deviation, and then went to the right again another deviation, that would give you x. Or in this case, you could write the equation that 15 plus 2 deviations is equal to x. And since they told you the deviation was 2.5, you could rewrite that equation as 15 plus 2 times 2.5, that's equal to x. Or simply x is equal to 20. So not hard at all, as long as you know the definition of the words you're looking at. There is one more term that you absolutely must be familiar with, and that is normal distribution. Normal distribution is a special case of standard deviation where you have specific percentages between each deviation within the set. Sometimes a normal distribution problem will give you the percentages within the set. Other times they will just say normally distributed, at which case you need to know that that means there are 2%, 14%, and 34% between the deviations within the set. And here's what normal distribution means. If you had a set of numbers and you had the average, 34% of the numbers are going to be between the mean of the set and the first deviation to the right. Another 34% will be between the average of the set and 1 deviation to the left. And then 14% are between the first and second deviation on either side of the set. And only 2% of the population, or the set, is spread out beyond the second deviation on either side. So here's how you're likely to see normal distribution. The passage tells us we have some times that are normally distributed. We have a mean of 35 minutes and then a standard deviation of 5. So we start by drawing our bell curve, and we draw in our percentages that we've memorized. 34, 14, and 2. My average is 35, and then each deviation mark signifies plus or minus 5 minutes. So my times are 35, 40, and 45 going to the right, and then 35, 30, and 25 going to the left. The question wants to know what percentage of times were less than 40 minutes. So they want to know this yellow region, everything to the left of the first positive deviation. So I just simply add my percentages, 34 plus 34 plus 14 plus 2, for a total of 84%. So super easy, but I absolutely had to know the percentages associated with normal distribution.